Now we're going to look at developing confidence interval for the estimate that we find using the regression equation. So we have the y hat, that's a point estimate for a given x. So a particular x, you insert the x value into the regression equation, you find y hat. Now that's the point estimate. Now if you want a confidence interval, and there are two different kinds of intervals that we can develop. One is the confidence interval for the mean of y. So for a given x, all possible y's that you could get from the distribution and the mean of that distribution. So what is the confidence interval for that mean? So that is given by y hat plus or minus the t table value times the standard error of that y hat, which is given by s sub yx. Remember, this is the square root of the mean square error times square root of a factor called h sub I, and that h sub I is given by this formula. So 1 over n plus x minus the x is the given x at which we want the confidence interval for mean of y, minus x bar squared divided by SSX, sum of squares of x. Now if you want a confidence interval for a particular y, not a mean of y, then the formula is the same formula like before, except that instead of h sub I, you'll have 1 plus h sub I here. Okay. The same h, okay, with a 1 plus h sub I. So let's look at how to compute these in Excel. Okay. So here is a question. Construct a 95% confidence interval for the mean annual sales for the entire population of all the stores that have 4 million profiled customers. So let's assemble the needed information. So we need n is at the top right here. Now we need x bar is right there. Okay, and then we need SSX, sum of squares of x, which is right there, and then s sub yx. So s sub yx is the square root of mean square error that we calculated here, standard error of estimate, which is that. Okay. Now the x value for which we want confidence interval is 4 million profile customers, so that will be 4. We have to make sure that the value for x is in the same units as the original sample data. The confidence level is 95%, and y hat for x equal to 4 will be b sub 0 plus b sub 1 times the x value of 4. So this is going to give us the y hat value, our estimate, and then we need the h sub I value, which is given here. H sub I is 1 over n, that's the first part, okay, plus x minus x bar, square that, divided by SSX. Okay, so that will give us the h sub I value. So now we can set up s sub y hat. S sub y hat is right here, which is you take s sub y given x times square root of h sub I. So that's the standard error of y hat. T table value is t dot inv dot 2t. Now we need to provide alpha value, so we need to go 1 minus confidence level, comma, degrees of freedom. Degrees of freedom, okay, is MSE degrees of freedom, which is right here. or we can get this from the data analysis regression output results also. So margin of error is t times s sub y hat, and then you go y hat minus margin of error, and then y hat plus margin of error. So this is the confidence interval for the mean of y. So for all stores with 4 million customers, the mean of the annual sales will be between these two numbers in $1 million. Now if you want 95% prediction interval, so you have to contrast between confidence interval and prediction interval. Confidence interval is for the mean of y, whereas prediction interval is for a given y, for one individual store that has 4 million customers. Then the s sub y hat is going to be slightly different. Instead of square root of h sub I, you'll have square root of 1 plus h sub I. So here s sub y hat sub p, the prediction value, is s sub y given x times square root of 1 plus the h sub I that we have computed already. Okay, so this standard error will be slightly larger because we are now talking about one individual case and not the mean. The t value is the same as before. So margin of error is t times the new standard error. So then lower limit is y hat minus the margin of error, and then y hat plus margin of error will give you the upper limit. And now you see that this interval is larger than the previous one, because previous one is for the mean of all the stores, whereas here it is for one particular store. So we have 95% confidence that the annual sales of a particular individual store with 4 million profile customers will be between these two numbers in millions of dollars. So you need to understand contrast between the confidence interval and prediction interval.